Hello, physics learner. Originally, I was planning to do the transformer explanation simply using the old video that I had, but I think it's better that if I can clarify what should be done more clearly, and I'll just try to do it again. So I will remove these simply, and I will explain these two pages again. And how you can learn from it. But before that, I would like to make sure that you have done something I would expect you to have done first. So first of all, I suppose you should have learning chapter 9 throughout, and you should have done the Faraday's lab simulations, and especially for transformer, I hope you still remember there was a part where it would expect you to have something called the mutual induction. I think should be right here, where you would have two coils that one would have the currents driving through it to produce a B field, the other side will have the currents induced on the other side so that you can have the EMF. And so in that case, this is the analogy, not analogy, this is a simple model of the transformer. So I hope you can have the experience of transformer through the simulation first. The second important thing that I would hope you can take a look before we start to learn transformer is, as I said, on the playlist there is a very good documentary made talking about the story between Nikola Tesla and Thomas Edison. And as you know, Tesla has been very famous nowadays because of Elon Musk. If you don't know who he is, this is Elon Musk, and of course he is one of the top engineer and of course businessman as well in the world, and owning a lot of different company including X-Space, Tesla. Of course, Tesla is simply the car company named after Nikola Tesla, this scientist, and also the Hyperloop as well, which is an underground train. And so of course he is like the Iron Man in our real world. Anyway, Tesla, and of course I suppose you know, is a car company making electric car and try to revolutionize the car industry. So why do we use would he use the name Nikola Tesla? Is because Nikola Tesla was one of the greatest, not just scientists but also an inventor in the world, because he invented the AC power grid basically. And this documentary again is very well made, although I recommend you to play in maybe 1.5 speed. Sometimes it's a bit too cinematic, too dramatic as well. It might be just to grab the idea between what happened between Nikola Tesla and Thomas Edison. And in short, if you want me to summarize the key ideas that you can find from this documentary, it was Thomas Edison was a very successful businessman by that time. As you know, his company has invented a lot of different things and made a lot of things commercialized. And the most famous thing that you learn from Thomas Edison is he so-called invented the light bulb, but of course he did not. He only improved the light bulb by changing it to changing the filament to tungsten only. In the past, there were light bulbs invented by other people. You can try to Google it, but then the lifespan was very short. It was like I think around 2 to 5 minutes only. But then he were able to increase it to many hours, and therefore practical enough to be commercialized. Nikola Tesla, being a younger scientist who is also enthusiastic in invention, he came to US to try to work for Thomas Edison. However, Thomas Edison tried to manipulate him by abusing his talents and also his effort. So basically, if you try to watch other video, you will find people will try to criticize Thomas Edison as change in acceleration over time. So at the end, Nikola Tesla quit because there was a time where there was argument between him and also Thomas Edison, and so he quit. And he also find the way that Thomas Edison insists using the DC for power grid was not successful. It would not be very efficient enough to develop further around the whole country, and so he find out there was another thing called transformer invented by Faraday, and he further developed that into an AC power grid, which actually can save much more energy and be much more efficient. And today, the reason why you can use electricity actually thanks to Nikola Tesla of his work, so that you can have the energy with such a cheap price and also so efficiently at home or at school and anywhere, even you are far away from the power plant. Okay, so definitely would like to want you to watch the documentary. If you didn't, go and watch it first and come back to this video. If you finish watching the documentary, I would then recommend you to look at the experiment which I filmed earlier in the physics lab. And so in that video, I will show you how the model of Thomas Edison and Nikola Tesla model in both DC and AC will work first. So of course at the end, this experiment will show you that Nikola Tesla, the one with AC and transformer, would be very successful in making the whole system very efficient, that means saving the energy, while Thomas Edison, that one will simply waste of lots of energy in terms of the power transmission. But I would like you to see the result first. So again, make sure you finish these all three parts before we start this video. Okay, so if you didn't, go and watch it now. If you finished already, then what we will cover in this video is I will firstly cover the basic principle of transformer in these two pages, page 22 and 23, and then in the next video I will explain more using a more quantitative way to calculate under the same scenario how Edison's model and Tesla model would give you a different efficiency. Okay, are you ready? So let's take a look of the basic working principle of the transformer here. So first of all, whenever you see a transformer in household, actually you could also have a transformer. So if you try to Google the word transformer, other than the movie, of course, you know, the robot, right, who doesn't like transformer, but then in physics you see photos like this. So this is a typical transformer model that we usually see, or this one, but more practically you may find photos like these things, right? And so how come I would say that you should be able to find transformer at home, and I'm 100% sure you have used it also. Do you know where you can find it? The answer is your phone charger. Any phone charger, no matter you're using iPhone or Android, even if you're using laptop, I'm pretty sure that you would have a transformer, because the transformer is actually one of the components inside the charger. And if you try to look at this video, this guy is trying to cut off, open the charger and try to see what is inside. And of course there's a USB port, and at the same time, again, I'm not recommending you to do that because you're going to waste your charger, and also it's quite dangerous also. But then I hope you can see that here this part is actually a transformer. Even this YouTuber, this video owner, also wrote that it is a mini transformer to step down also. So later on, if you try to read the textbook, you'll find out there are two kinds of transformer. One is for stepping up, one is for stepping down, and this one is stepping down, meaning that the voltage is going from a high voltage changing to a low voltage. So why do we need a step down transformer then, right? Think about this. If I try to go and Google the page for the Apple power adapter, which means your charger, you'll find there's a label, or you can simply go and check out your own charger. There's a label on top of it. And since you learn physics, and I hope by now you should be able to learn the meaning of at least most of the words there. So that will include, these are not so important, but the numbers, 10 watt means the power, how fast you can charge your phone. And the model number is something to do with their own company. Here is something more about physics. So it said the input is 100 to 240 volts. If you recall what you learned in the previous chapter, then it's something to do with the input circuit, the main power. In Hong Kong, it is 220 volts, and so that's why you can use such a phone charger in Hong Kong. But the thing is, for powering up your own phone, you do not need that high voltage. If you apply such a high voltage to your phone or to your lithium battery, your lithium battery is going to have problem on overheating, which means it will soon explode. So using this AC, since you can see the hertz means the frequency of the AC power source, then you can see here output is 5.1 volt, and then you can see the line here actually means it is direct current, which means that what this phone charger does is transforming this high voltage to a lower voltage, which is suitable for your lithium battery in your iPhone to be charged. So this is a safe way to do, and also this is the same way for us to use many other electrical appliances also. So this is something that you could learn, and I do find learning transformer is actually very relevant to your daily life. Even if you're not doing anything with physics in the future, you're not studying physics in the future, this is going to be very relevant also. Okay, so before I explain these two pages, I would strongly encourage you to pause the video now and take a look at the textbook, try to find out all the answer first. Okay, so let's take a look of the basic principle of the transformer first. So first of all, you have to realize that in the experiment also, I mentioned that for transformer, you have to use AC. If you use DC, you cannot have any result. You just waste your energy. And that is because we have to manipulate the nature of AC, that means the alternating current. So imagine in this diagram, there is a primary coil and secondary coil. We call it usually N1 and N2 for the number of turns in each side. And so when there's connected with AC source, then current will flow back and forth here. So there are usually several steps that we will do, which actually we have covered in the simulation, but I would like to cover it again. So maybe we can write it down also. So first step is you have the AC, which means the direction of current changing all the time. You can try to lengthen the whole sentence. And then as a result of this, since current, you know, it will induce B field, right? Then the induced B field direction will be changing as well. And therefore, you can imagine the magnetic field is going up and down and up and down very quickly. How quick would it be? If the AC will be, say, 50 Hertz, which is a very usual frequency, then imagine the B field is changing 50 Hertz. This will be similar to in the simulation, you try to push the magnet back and forth, but now you are more like doing automatically. In that case, the B field that got transmitted through to the secondary coil, because with the help of iron core, remember this is something that it can get magnetized. And therefore, in the video, we also use something the same called the iron core to help as well. In the secondary coil, it would experience the change of B field direction, and according to Faraday's law, that's why this is made by Faraday, because he also first of all observed the nature of the world first, and then he tried to take advantage of this. And therefore, the secondary coil can experience a change of B field and therefore induce the EMF since that whenever there's a change of B field, there will be induced EMF, and therefore you will then next induce the current I if you have connected anything here. So this is a basic working principle of the transformer step by steps, which usually you need to write like this way in the exam. And the whole process is called mutual induction. Okay. Yeah, I think this is basically what I said here. And in IGCSE, usually we'll assume the transformer has 100% efficiency. However, in reality, they will be, of course, not as efficient, and that is something to do with the magnetic field could not 100% go to the secondary coil. Some of them may, try to be kind of fade out to the surrounding, and that is something you cannot contain every single magnetic field inside. And also there is something called eddy currents, which we also covered in the video earlier. It's something to do with whenever there's a movement, then you could generate some eddy current within the core itself, and that would take away the energy from you in a form of thermal energy. Alright, of course, first of all is electrical energy, as it is a current, but later on it will just simply dissipate as heat, so thermal energy at the end. If you're okay with that, then let's just introduce some formula. The ratio of turns between the two sides will affect the ratio of the voltage. So therefore we have an equation. It's very simple to remember. Simply is the N on each side and the V on each side. 1, 1, 2, 2. That means that the side with more turns would always have higher voltage, no matter it's stepping up or stepping down. So this is the first equation you have to learn. The second equation is based on the facts, not the facts, but the assumption that we assume it is 100% efficient, and therefore it means the power loss is 0, and that means the power in primary side and the power in the secondary side would equal. So power 1 equal to power 2, and since you know power equals to VI, and therefore we have V1 I1 equals to V2 times I2. So this is the second equation that you will probably use quite a lot whenever involve the transformer. Okay. And now let's take a look of the name. Again, step up or step down. So here it said increase the voltage, so this must be stepping up. Step up transformer, step slash up. Sorry, not slash, hyphen. Step hyphen down transformer, decrease the voltage. And in terms of the number of turns, then stepping up, so later on you have more turns, right? And so, or you can deduce here, if N2 is higher, then V2 is higher, if you keep these two fixed. Okay, so N1 should be smaller than N2, and for stepping down it will be opposite. N1 will have more turns than N2. Okay, so for example, if you still don't get it, you can imagine that, let me erase this. You can imagine that on the primary coil, that side, if you have, say, 5 turns, N1 equal to 5, while for secondary coil you have N2 equal to 100 turns. Then you can see the ratio is 20. It's like times 20 here if you try to look at the ratio. And so in that case, for voltage, if the voltage I input for the primary is, say, 10V, then the voltage on the secondary coil, that side, will simply be 20 times larger, which is 200 in that case. So you could, of course, still use this equation to help, but this is a brief idea. And since the power is the same, then it actually means that the since the voltage is higher when you're stepping up, then the current has to be lower in that case, and therefore it will be opposite. Current in I2 will be less than I1 because the voltage has increased instead. For stepping down is simply the opposite, so the answer is this one. Some people may like to see or use another equation. So other than the equation here, that is, I will try to write again, that is n1 over n2 equals to v1 over v2. And by the way, this equation you are not able to prove it in IGCSE yet. But if you, of course, if you are really interested, you can try to Google it, and you will be able to find some deduction, especially something to do with the expression of B field. Then you'll be able to prove it. But of course, if you're not that interested, I think that's fine for now. You can just leave it first, and just to remember there's an equation like this. And if you try to deduce further, some people may like to also write the relationship between the I. So what should I write here? Do I still write 1 and 2 here? The answer is no, right? The answer is opposite. And that is simply because you could try to look at these 4 things from these 4 things, right? Which you just rearrange the I in one side, the V on the other side, put together. And then you should be able to obtain this equation. Okay, so this is the basic idea of transformer. Let's take a look at the next page. So next page here is set for power transmission. So similar to the experiment that I showed you. The problem with the urban power transmission is people are not living exactly close to each other, right? So you must have to transmit the power through a long distance across a city, especially for cities not like Hong Kong, of course, it's so compact, but for other cities around the world, it will be so far away from each other. And we will have to use AC. And by the way, the reason why we have to use AC, back to the transformer, is imagine if you use DC, then the direction of current would not be changing, and therefore the B field direction would not be changing, and therefore the B field experienced by secondary coil, yes, you can experience a B field, but then it is not changing. And according to Faraday's law, it has to be a changing B field for inducing the EMF, right? So without the changing B field, then you cannot have the EMF. So that's why transformer, if you use DC, is wasting your time, wasting your energy, wasting your money. Sorry, back to here. So for power transmission, you have to use yes, AC current. Actually, I should say AC, because the C already stands for current. Alright, sorry for the mistake here. Anyway, since power loss in a resistor is you can use different equation, including I square R. You could technically use V square over R and IV, but then I will strongly recommend you to stick with I square R. I would explain more later on when we try to do the example in the next page, which is next video. But then the main idea is that you actually don't know the voltage drop. Whenever we talk about V here is the potential difference. Whenever we talk about the step up voltage, is talking about the whole secondary coil voltage. So it's a little bit different concept. I'll explain further in the next video. So in that case, if you try to look at this equation, since R is fixed, then with a lower I, then the whole power loss will be lower. Okay. Well, if you try to say, oh, what if we look at this, then oh, if current decrease, then we can also reduce. But then V actually increase. So you probably cannot explain that easily. Actually you can, but then I don't want to confuse you, so let's just stick with this equation for now first. The other thing is since the transmission cable, like those you see around the mountain when you go for hiking, you usually see those transmission cable and station, they are many kilometers long, so simply very long. They must have great resistance, and therefore we need to have the step up transformer like what we explained here to increase the voltage and decrease the current, so that's to decrease the power loss in that case. And of course, on the other side, in your household, that side, you will have, of course, the step-down transformer to make the voltage usable back to 220. Okay, so that is all for these two pages, 22 and 23.